In this video, we'll be modeling and solving addition and subtraction word problems. Before we get to our word problems, I want to address the issue of key words. I've gone to Google and searched for addition and subtraction keywords. Here we have images of posters that you might see in an elementary school classroom. I want to point out a couple that we'll be using in today's examples. On the subtraction poster, you can see that we have the word left. Left is a keyword for subtraction. On the addition poster, you can see that we have the keyword altogether. Altogether is a keyword for addition. As great as keywords are, they can be a little bit confusing, and that's because keywords match the model of our problem, but not necessarily the solution. Let's look at a couple of examples. Altogether, we can see that this keyword went with addition. Altogether, an electrician used 14 meters of wire on a 2-day job. If she used 6 meters on the first day, how many meters did she use on the second day? So this problem is what we would consider a missing addend problem. The model of the problem, the way we set it up, is we say, well, she had 6 meters on the first day, some unknown amount on the second day, for a total of 14 meters. So this is an addition problem. 6 meters plus some more meters gives us 14. But because we have a missing addend, addends are just some of the terms that we add together, we're going to end up with a solution that uses subtraction. The solution is 14 minus 6 equals 8. So we solve it with subtraction, but the key word matches addition. When we have the case of a missing addend, then we solve with subtraction. Often it helps to draw a visual representation of word problems to understand what's going on. So let's draw a couple for this one. When we have measurements like meters, those are continuous amount, and a number line can make sense. So let's draw a number line here. And we might represent this with an arrow that starts at 0 and ends at 6 to represent day 1. And then we might draw another arrow that starts at 6 and ends at 14, since that's the total amount, maybe even one summary arrow here to show the total of 14. So we have our 14, we have our 6, and our unknown amount. So we'll have to subtract to figure out what we have. Oh, and let's label this with meters for our units. Another way to represent this would be with what we call a strip diagram or a bar model. So with a strip diagram or bar model, we don't worry a whole lot about having relative amounts correct. So what I mean by that is I'm going to draw a strip or a bar right here, and I'm going to split it into 2 parts, and it doesn't matter if I've split it correctly. It's more important the number of parts, 2 parts. So I'm going to label this day 1 and day 2. And then across the top, I'll have my total amount. So whether we're dealing with addition or subtraction, the same kind of bar model will work. We'll stick in our known values, 6 and 14, and our unknown. So we consider this a part, whole. Part, and the whole right here. And if we know both the parts, we add them together. If we don't know both the parts, if we know the total in one of the parts, then we subtract to get the missing piece. So here I can just set it up, day 1, day 2, and then realize I'll need to subtract to get my 8 meters on day 2. That problem had a missing addend. The model was addition, and the solution was subtraction. Now let's look at a missing minuend. Bobby bought a pack of gum. He chewed 2 pieces of gum on his way to school. Now he has 8 pieces left. How many pieces did he originally have? So left was one of those keywords that I highlighted for subtraction. But remember, the keywords match the model. So in this case, the model is that Bobby had some amount of gum. He chewed 2 pieces, and now he has 8 left. So it's a subtraction model, but it's this missing minuend. We're missing the first part of our subtraction problem. So how do we solve this? We solve this with addition. Let's draw some visual representations. In the last problem, we had a measurement, a continuous amount of wire, and now we have discrete objects, so we'll go with a discrete set model. So here we have a set of gum, and 2 pieces get chewed, so those get taken away. And we know that we have 8 pieces left. So after we take those 2 pieces away, we have a total of 8 pieces of gum. So we can see that we would add those together to get the original amount. Now let's look at our bar model, our strip diagram. Again, it doesn't matter that I get the proportion right in my strip, but I can just fill it in. So now I have 2 pieces chewed, 8 pieces left, and I want to know the total amount. Since I know my 2 parts, I can add them together to get the total of 10.